Question 3.7. We are not going to assess this section. We will introduce it. It is information that will be beneficial for Algebra 2. This is typically introduced, I mean, midway through your sophomore year when you take Honors Algebra 2. But in 3.7, we're talking about shifts and transformations of linear equations. So we have two graphs here. And the first graph is f of x. So if we see f of x equals 1/2, we can graph that. We know what that graph looks like. It's relatively straightforward. It has a y-intercept of 0. And it has a slope of 1/2, so it looks like this. Yep, that's correct. And so we get this. I swear, smartboard. I swear, it's supposed to be good. It's supposed to be technology, but you rarely work. So what are we doing? What are we doing with this? It's being affected by this next graph. And then it wants to look and see, hey, what if g of x equals f of x minus 2? So when, this is an interesting one. So when you want to find g of 1, you're going to find f of 1 and then minus 2. So we're going to find f of 1. So off to the side, we're going to find f of 1. Let's do that in blue. So f of 1, that didn't go blue, equals 1/2 times 1. So f of 1 equals 1/2. So we're going to substitute 1/2 in for that. So g of 1 equals negative 1 and 1/2. So now I'll really go blue. So when we plug in 1, we get negative 1/2. 1, negative 1/2. So that's going to be my g function that I'm graphing. Now if I want to find g of 2, I'm going to plug in 2 in for f and minus for 2. And we'll go back up here. So, oh man, what are you doing, smartboard? So if we're going to find f of 2 equals 1/2 times 2, so f of 2 equals 1. So we're going to plug in g of 2 equals f of 2 equals 1 minus 2, so g of 2 equals negative 1. So plug in 2 and you get negative 1. So that's that point. So my slope continues to go like this, and this, etc. And then if I graph that, let's graph it in blue. So it kind of looks like that. Yeah, that's not bad. And so the question is, what's happening to that graph? What's happening to it? Well, it's being shifted to. I don't know if you see that. So what's happening to it has a vertical translation of 2 down. It took this black graph and it shifted it down 2 units. So when we want to talk about what's happening, we can either graph it or we can also look at it, and that's what we're trying to show here is we don't have to do the labor-intensive graphing component. We can actually derive this information from looking at it. And so I have this little reminder. Remember, horizontal is inside and inverse, and vertical is outside. So what's happening when we go to g of x? We see that it's on the outside. And outside is going to be vertical, and so -2 is going to be up and down. So that is down 2. So it's a vertical shift down 2. That's how we would describe it. So if we wanted to describe it, it's a vertical shift or vertical translation 2 units down. 2 units down or down 2. I've written either one. So we're not going to use the graph. We are going to look at and evaluate. So we see this time it's inside. So inside is going to be the inverse of what we see, and it's going to be horizontal. So this is a horizontal translation, and it's going to be 3. Now negative is to the left, but it's going to be to the right. 3 to the right, because we're going to do the opposite. So this graph would be the parent. This is its parent, and it would be shifted 3 to the right. So all we would have to do is do this graph and shift it 3 units to the right. That's what's going on. That's how we're doing. That's how we're able to do all this without any of the heavy lifting of graphing all these equations. So what's happening here? This is inside again. So inside is going to be a horizontal translation, and it's going to be 4 units to the left. Left because it's the inverse of what we see. So 4 units to the left. Let's do this. I don't think I can do that. I got to do this. Let's take this away. And what's happening here? So we're going to take this graph, and now this one is on the outside. So it's vertical. So this is a vertical translation of 1.5 units up. So outside is up and down. Inside is left and right. That's the other thing that we should sort of make sure. So 1.5 units up, a vertical. Let's look at this. We have this. So, now, so inside, when it's a negative, it's going to be a reflection across. It's going to be a reflection across the y-axis. So it's going to reflect it. This is x, y. So if you have this, it's going to reflect it across the y-axis, which is kind of cool. So every x value will be reversed. And that's sort of what it looks like. It says the opposite of x. So if this was, the point 7, 5, its reflection would be -7, 5. Because we're just flipping the x value. The x is going from positive to negative or negative to positive, depending on what our original input, with a slope of 3. How do I know it's a slope of 3? Because that's what the parent was. Let's look at this. So this time the negative is on the outside. So the outside is going to be a reflection across the x-axis. Okay, so that is going to be a reflection across the x-axis. It's outside, that's up and down. So remember, horizontal is left and right, vertical up and down. So it's going to affect that. So that's the same thing. It's going to take this line and it's going to reflect it across the x-axis. So this now becomes this. So if you have this point, let's make that 2, 8. The reflection is going to be 2, -8. Okay, so because that says the opposite of the output, and our y's are always the output. Logic-wise, you can look at it in that manner. Delete. Okay, so now we are on the outside, but this time it's a product of. So this one is going to be a stretch. So that's going to be a vertical because it's outside. So it's a vertical stretch of a factor of 2. And if we think about it, if we take all those values and multiply 2, it's going to stretch it twice as big. Yes. Any value that it gets produced is going to be doubled. The output is being doubled. F of x is the output. We're going to multiply it by 2. This one is a little bit different because it's on the inside. So inside, remember, is inverse. So this is going to be a horizontal shrink. Oh, excuse me, not shrink, because it's going to be the inverse of 1/2, which is 2. It's going to be a horizontal stretch of a factor of 2 also. And now that's where it gets tricky, because a lot of students will make that mistake as they think that is a shrink. But it's not, because it's inside. So we have to be very careful about the difference of inside and outside. And inside is always going to be the inverse of what we see. So kind of tricky. That one definitely is one of the more trickier ones. Number 9. So inside, and it's the inverse. So that is going to be a horizontal shrink of 1/4. So 9 is a horizontal shrink by a factor of a factor of shrink of a factor of 1/4. A lot of ofs in that. And last but not least, number 10. So what do we have here? That's on the outside. So it's going to be a vertical shrink of a factor of 2/3. So vertical shrink of 2/3. Yep, vertical, good. Now 11, we're not done. I thought 10 problems, but we keep going. G of x, so now this is going to have 2 things happening to it. So notice there are 2 things that are outside. The first thing is, and they're both outside, so it's going to be a vertical shift, or no, vertical translation down 2 units, and a stretch, a vertical also, we'll just vertical translation 2 units, and a stretch of a factor of 3. So a vertical stretch and a vertical translation. So both of verticals, both for vertical vertical down, and a vertical factor, stretch factor of 3. And I think this one is truly the, no, not the last one. What are we doing here? Again, everything's on the outside. You have that, so that's a vertical, and that, and that. Oh, you got actually 3 things. So it's first, it's going to be a reflection across the x-axis. Because vertical is up and down, so across the x, that's going to be 1. It's going to be a vertical translation up 1 unit. And it's going to be a stretch, a vertical stretch of a factor of 2. Right? Oh, my bad. My bad. Sorry. And this was the trick one. So this does not get done. There's actually only 2 things happening. Sorry. I knew there was a tricky one here. Okay. So what's the difference? Right? If this is the parent, well, that parent is right there. So what are the things that are happening are these 2 things. So I made a boo-boo. I knew this problem was here at some point. So we only have, let's actually make that a different color, and then we can show what that is. So a reflection is green, and then the vertical translation is yellow, and the 2x is still there. So that's the parent part. So that's not, it was already being, it already had a 2 factor. So there's actually only 2 things. Sorry. All right. Now, so what's happening here? It says find the value of r. So because we are inside, if this is the parent, and if this is the parent, and we're inside, inside deals with up and down. Remember, up and down, left and, no, left and right, sorry. This deals with right and left. And vertical is up and down. So since we're dealing with inside, we're going to do right and left. So how much does this graph go right and left? So if we look at it, it's going to go right 1, 2. Okay, so it goes 2 to the right, but because it's the inverse, we're going to say that that is f of x minus 2. So that should be our r is going to equal 2. So r equals 2. Super, I know it says you wrote -2, but there was already a negative there. So it asks for r is going to be 2. It's a little bit tricky. Here is the parent. It's getting chilly in here. Let's turn that off. So here is, no, let's do green. Here is the parent equation. So it's this graph. And then it wants to know what is happening to this. And it wants to know what is r. Well, r is on the outside and it's being multiplied, so it's going to be a stretch factor. So a stretch factor, so it's stretching or shrinking. Stretch or shrink. And because it's outside, it's not going to be the inverse. So we want to see where does it go. Well, if this point is 0, 2, and then my new point there is 0, 1, how do I go from 2 to 1? Well, my r needs to be 1/2. I'm taking 1/2. So my r value is 1/2. All of those points go to 1/2. If I take this point, 1, 1, we notice that this becomes 1, 1/2. Same thing, all is good, That would be your R value. A little complicated, definitely complex, but this is a good base, a good foundation. So when you see it and your Algebra 2 teacher teaches it to you sophomore year, you will have a good foundation and understanding of how to recognize translations.